Hi, this is John, and welcome to another edition of Statistics Tell a Story. Today I want to talk to you about hypothesis testing and how it relates to trends, particularly in the NFL. So, first of all, a hypothesis test, and some of you in a collegiate statistics course might well have taken this, is very similar to a court trial, right? You know, what does the prosecutor do in a court trial, right? Tries to get evidence, strong evidence, to prove conviction, okay? Very similar here. So, but we do it with numbers. So we have what's called a bell-shaped curve, and not that every hypothesis test revolves around a bell-shaped curve. The great majority of them do. And we have an assumption, right? Just like in court, we have an assumption that you're innocent, right, until proven guilty. Here we have certain assumptions, and in particular, this is going to be a test of one proportion. There's many different tests. I'm just going to go over one. And we might assume that the probability of something is 50%, right? Not necessarily, but for example, flip a coin, right? We assume the probability of a head or tail is 50%. So it's kind of a good starting point. If we know nothing else about two teams, right? And, you know, somebody who doesn't follow football, you're saying, well, you know, what do you think the probability that a certain team, the Steelers, cover against the Packers? Not knowing anything else, say 50%. Okay. And we're going to see if we can get information sufficiently far away from 50% to kind of prove or show conviction that we think there's something to this trend. Okay, I'm going to give you one example that I heard. This was actually on a YouTube telecast. And you hear all kinds of trends, right? You've probably heard them, especially if you watch some of these YouTubes and these prognosticators. And it is in the last 20 years, the underdog playing the 1 seed and getting less than 10 points in the divisional round is 25-10 against the spread. ATS is against the spread. Saying, so, oh, that's pretty impressive, okay? Well, we can do a hypothesis test. Now, it's very important, I don't want to get too much in the weeds here, but I do need to mention this, is there are one-tail tests and two-tail tests, okay? And, you know, we could probably say for another episode as to, you know, exactly why, but on the surface, I'm going to tell you that whether it's a one-tail test or a two-tail test depends on your beliefs, kind of going into your study, okay? And sometimes you may not have any, you know, prior beliefs. So in this example, we might say, well, we're looking back on the last 20 years, and we happen to notice this trend. Well, what was our prior belief, if any? Well, we really didn't have one, and we're trying to see if this is significantly different. I'm going to emphasize the word different. If we believe that this is different than the norm, then we would call this a two-tailed test. Don't get too hung up on this, but I do want to mention that. So we call it a two-tailed test, which means that if we want to prove that we are far enough away from this assumption, we're going to need to look for evidence on both tails, okay? Well, we can use, of course, in today's day and age on the internet, we can use a calculator to find what is called a z-value. A z-value is simply the number of standard deviations from the mean. To put that into context, Many of you probably know the average IQ is 100. Standard deviation is 15. If somebody has an IQ of 130, they are 2 standard deviations to the right of the mean, which is pretty good. So just to give you a sense of standard deviation. Okay, so what is this z-value? If we can do this longhand, but we can also do it, like I said, on a calculator, and we would find that the z-value is, I'm going to put it over here, it's 2.54. Okay, now that's pretty far away from the mean. And this is 25 out of 35. It's 2.54 standard deviations from the mean. Now, this is very important. So just like a prosecutor is looking for rare evidence, for example, if a prosecutor were to find one eyewitness to the crime and maybe they have credible or questionable character, that's not a real strong argument. There's a decent chance that that eyewitness is telling the truth, but it may not hold up in court because there's a decent chance also that they're lying, right? So much like a prosecutor looking for extreme evidence, right? So if a prosecutor finds 10 eyewitnesses and they all say the same thing, that they saw this person committing the crime, if we were to draw a picture of that, the prosecutor is finding really rare evidence, very extreme. And we would say that, well, what are the chances that that extreme evidence happened just by chance? Pretty rare. All right, same type of thing here. So we might say, well, what is the chance that this happened by just random chance? The probability is the sum of this area and this area. This was why it was important to define this as a two-tailed test. If it were just a one-tailed test, it would just be this area. So the sum of this area is going to define our rareness, okay? The more rare, the stronger our conviction, just like in a court trial. Well, what is this area? It's actually 0.005. Meaning this area, which is to the left of negative 2.54, is 0.005. If we add up 0.005 and 0.005, we get 0.01. Now, this is where it becomes kind of discretionary. Is 0.01 a rare enough area to put any strength in that trend? Well, we're getting rare. Me personally, 0.01 is kind of a cutoff that I would use. A lot of people would use 0.05. Again, you might remember that from a basic statistics book. The most common cutoffs are 0.01, 0.05, 0.10. It's discretionary. But 0.01, we're kind of getting there. However, I'm going to put a caveat on that. Notice that we said, on the previous paper, it said 10 points or less, right? Well, we put a boundary. Boundaries kind of weaken arguments, okay? This is not something you're going to find in a textbook. I can just tell you from experience that, the more filters you put on something, in particular a boundary with a number, the weaker it becomes because you're kind of cherry picking. And in fact, if we were to look at, again, that same 20 years, if we were to look at all underdogs, not just 10 points or less, all underdogs are 26 and 14. That's not quite as strong as 25 and 10. If we were to do a hypothesis test, just as I did before, right? Use the calculator. We would find, instead of 0.01, which by the way is called a p-value, we would find it's 0.06 for 26 and 14. The lower the p-value, the stronger your argument. The higher the p-value, the weaker your argument. So now 26 and 14, maybe it's not so strong. So what did that person do that said 25 and 10? They were cherry picking. Okay, so what is my point? My point is that with trends, you need to be careful, okay? I'm going to give you some rules of thumb here in a second. I do want to mention something that is a little bit different than hypothesis testing, It is called Bayes' theorem. I've actually mentioned Bayes' theorem in other telecasts. And Bayes' theorem can be used kind of in different ways, you might say. But one way is to, the whole crux of Bayes' theorem, and again, this is a whole other episode, is that you can update probabilities or predictions, okay? So whereas a hypothesis tester might do a hypothesis test and say, we don't have enough evidence, okay? We're not going to put any stock in this. Or in a court trial, right? If you don't have enough evidence, you find not guilty and they don't go to jail at all, right? They're off scot-free. Bayes' theorem is a little bit different. So for example, you have let's say you have a general manager, right? Or a scout, and they're in a minor league game. And they know that the typical minor league hitter that they look at, on average, they're going to have a 270 batting average. And they see this hitter, and they're at the plate one time, and they get a hit, right? And you ask this scout, well, what is your best prediction of this person who you knew nothing about? What's your best prediction of this hitter now? You'd actually say it's a tiny bit higher than 270. Why? You have a small sample size. It's just one at bat. But that one at bat does mean a little bit, at least to the Bayesian. It may not mean anything to the hypothesis tester because that's not near enough to convict. But to the Bayesian who wants to update with every instance, it's a little bit better. So the same thing can be said with a trend. I'm not saying to discard trends. And in fact, to the Bayesian, that trend, instead of 50%, might update your prediction knowing nothing else, might update it to 51 or 52% against the spread, whatever it is. But it's not quite as strong as that 25 out of 35 might appear to be. That's the point I'm making. Okay, I'm going to give you just some rules of thumb for trends. If you really want to kind of put some stock in trends, number one, do a hypothesis test. Okay, again, I'm going to put on this video in the comment section, I will put where you can find a calculator for a test of proportion. It's easy to do, okay? Number two, be wary of cutoffs. Just like in the example I gave, right? The more cutoff, well, for a cutoff, it weakens the argument. Number three, be wary of filters. The more filters you have, the weaker your argument, okay? What's an example of that? You might see a trend that a team, say in the last 15 years with a certain quarterback, on the road, maybe with a certain surface that they're playing on, etc. With every one of those caveats, you have an additional filter, or we might call it a parameter. Your argument becomes weaker. Number four, is this a well-known fact? Why is that important? Well, the more well-known, the more the bookies are probably aware that the public now knows about it, and the bookies might be adapting, okay? Number five, use some subjective analysis, okay? Do you like their coach? And so forth. Now, again, it takes a very astute person to end up beating the books. You basically have to hit 53%. Might not sound that hard. A little harder than it might appear. So that's why most bettors, they don't win. If they hit 50%, they're going to lose what's called the juice. Use some subjective, which I do, okay? I'll give you a good example. This week coming up, the Houston Texans actually would be part of that 25-10. And in fact, this same telecast that I'm referencing, they were advocating to bet the Texans against, they're getting 9.5 points against the Ravens. Couple things on my end. I actually put a little bit of money on the Ravens. Why? Number one, there's a couple reasons. Just real quick, I'll mention. Number one, I don't put as much stock in that 25-10 as some might. Number 2, I love the Ravens coach, John Harbaugh. I think he's the best coach in football. Number 3, I think the Texans are going to let down. They have a rookie coach and a rookie quarterback that are now on the road playing a much bigger game than they did last week. So, you know, again, I'm using some subjective. So use some subjective evidence or analysis. Trend, probably the best way if you really want to bet trends, and I know this is a lot of work, but for the few of you that might want to do it, you get a big database and, you know, maybe you get somebody to code it or whatever in Excel. I know it's a lot of work, but, you know, just like to beat the stock market, if you really want to do this right, you can't just necessarily listen to any flimsy trend that you hear online. I will say that what I have found, I'm just going to give you a little tidbit, that I have found a potentially strong trend. This is very general, is going against I'm going to say mediocre team that has been winning and then they play a strong team. And I'm also using some subjective, you want to ask yourself with any trend, does it even make sense, right? Some trends are nonsensical. You know, you might have a trend that I don't know, a certain team, you know, after they play the Lions, they're 1-10 against the spread. Does that really mean anything? I mean, is there something special against the Lions or whatever team, okay, that there's relevance for that? Or, you know, maybe it's in October or whatever. You just see all kind of weird trends. Now, why do I think this trend might mean something beyond the numbers? Well, teams let down, right? So if you have this hot team and they're mediocre, I would believe that they're a little more apt to let down than a good team, right? You know, you have Bill Belichick, you know, his Patriots, one year they went 16-0, right? They could win 4 in a row. It's nothing to them. They expect to win 4 in a row, right? At least back in the day, right? But you have an upstart team. They win 4 in a row. Maybe they're on cloud 9. They feel like they won the Super Bowl. So I think they're more prone to a letdown. What else might be happening? They say the public and the bookies, they're going to cater their lines to recent weeks. So that line might be inflated towards that upstart team because they remember maybe in the last 3 or 4 weeks, they've looked like world beaters. Okay, so perhaps the line is geared against them and the market is overvaluing them. So things like that. So again, you want to be careful of trends. But anyway, I just wanted to kind of give you a nutshell that most of the trends you hear, be leery of. I'm not saying it's not something to maybe put some stock in, but in and of itself, they're generally not enough to bet on. Again, a lot of you're going to want to bet no matter what. Okay, well, it's maybe better than nothing, but just be leery of trends. Anyway, so that's about it. I'm going to wrap it up. Thank you for tuning in. Please hit like and subscribe. It helps the algorithm. It's much appreciated. And I will see you next time on Statistics Tell a Story. Thank you.